All right, what is up, everyone? Welcome to week 69 of Chill Kernel Hacking for Fun. This week is going to be pretty interesting because we are actually kind of starting a new chapter with all this streaming stuff. As of last week, with week 68, I reached the end of the MIT course, which is what I've been doing all this time, basically. As of last week, we got all the way to the end of Lab 6, and we had this web server working. And that concludes basically that chapter of streaming. So at this point, I've fully completed, with an asterisk, I've fully completed this MIT course, and I've learned a lot about operating systems and how to build them. And I feel a bit more prepared to actually start over with my own operating system, which is written a bit more from scratch. So that's in general kind of what we're doing now. And I have a little list of kind of like bucket list kinds of things that I want to do. Actually, I wonder if I have it over here. Yeah, this got kind of messy, but here is roughly what it is. So there's a bunch of topics I want to learn about, like GRUB, multi-boot, Limine bootloader, and UEFI. So far, we've just been using this custom bootloader. It's this legacy master boot record bootloader. And it's nice and it allows us a lot of flexibility, but I just get the impression that it's not like really the most professional way to do things, and rather integrating against an actual bootloader would be like a bit more of a standard setup. So yeah, those are a couple things I want to learn also about 64-bit mode, accelerated system call instructions, vert.io. So that's a bit of a general overview. Today I want to look into GRUB, because that's just a kind of a very concrete thing that I'm super curious about. So that's what we're going to do today. Before we immediately just dive in, as usual, we should just take a look at the Git history and see where we're at.
You'll need to unlock your iPad first.
My Siri just opened up on my iPad over there. Okay. Yeah, so I guess our working tree is actually clean, and we are compiling and everything as usual. So I think we are in a somewhat reasonable state here. I think the only issue is that currently the OS is set up to start the web server when it boots up, and I kind of want to revert that for the moment. There's a bit of all this infrastructure which I never completely understood about controlling what gets launched at startup, but and there are some helper command line utilities that somehow you can use to change the init process without actually modifying the kernel source. But here's just how I am doing it. I'm just patching it, and this user icode thing is actually a more legit init process that starts a shell. And so, yeah, look at how slow that is. That's so interesting. I wonder if it's because of this. I wonder if our network stack is responsible for slowing things down a lot, because we currently do have this super inefficient and very wasteful implementation that basically just spams the driver in a loop waiting for packets. And so actually what I might do is insert a sysyield. See if that, look at how much faster that is. Yeah, that is very interesting. So basically what was happening before is this process is in this insanely hot loop, just doing a system call to ask for new packets, and the system call just returns with an error in case there were no new packets. And in general, for most of the time, there are just no new packets, and so we're just absolutely wasting so many CPU cycles with all it's just literally constantly doing system calls and going into kernel mode, which also grabs the global kernel lock, which makes it hard for anything else on the system to do anything. And so look at how much faster that is now that we are actually yielding the CPU on every loop and allowing other things to get some CPU time. Maybe it would be good to just quickly check that, I don't know, the networking echo. Does this work? Okay. Yeah, okay, so I'm just running our echo server right now. And we can see that the echo server is still working. And so we didn't like completely break things just by doing this. So I'm going to I'm just gonna amend this into here. Okay, that's just a little bit of a side quest. That's a bit better. So now our shell is a little bit faster. Well, it's a lot faster. Okay, and now we have a nice clean working tree. And so now we're ready to get started on this grub stuff. And this is potentially going to involve a lot of changes. But what I'm actually, I'm loosely aware of actually that there is already some grub support. And by some grub support, I mean 3 lines. What happens if I try, so make grub basically doesn't do anything except for this one obj copy command, which I don't actually understand, but maybe that's useful. I don't know. Make grub. Okay, so that did something. Yeah, so apparently that worked. I don't really have any idea what that actually means, but apparently now we have this JOS grub thing. Yeah, so what's going to be involved here? So I know very little about grub. We're going to need to, well, also we're booting with QEMU, because QEMU grub supports. In general with grub, I believe all we need to do is somehow package the kernel elf. And we need to make the grub config, and then maybe a multi-boot header. So I'm just going to look for this. How to grub boot. And maybe just for moving a bit faster, I'll also get just a ChatGPT search going. Yeah, in case that helps me move faster here. I have an existing hobby OS which has a custom bootloader, custom 16-bit ASM code, which loads the OS. I'd like to port to using GRUB. I'm on a M1 ARM MacBook. What's the easiest way? I'm using QEMU for emulation. Currently, I have my boot sector, which is 512 bytes, and I append it directly to the kernel elf to create an image file, which I pass to QEMU as a disk. And just curious, what okay. My options. Get this working with GRUB instead. Okay. I guess I need some command line tools. Yeah, well, that would be kind of unfortunate if things did not work on Mac, but I guess we'll see. So the idea is to make a GRUB ISO. Your elf should start directly with multi-boot header and entry point. Okay, that's useful just to get oriented here. So step one, multi-boot. Yeah, so there's this multi-boot thing, which I don't totally get. I have some loose understanding that you have some magic numbers that the bootloader scans for, or something weird like that. Create a GRUB bootable disk image. Then we have some folder structure that somehow this matters, like, okay. So it creates a directory with boot grub, copies it into copies the kernel into /boot, but then there's this extra grub directory and copies the config into boot grub, and then make a rescue. So first thing I'll just do is brew install grub. Interesting. There are a couple options here. Which one do I want? Native OS? What is this? I think, I wonder if I should use this. Updated last year. I believe I'm actually already using the compiler from this project, so I'm sort of inclined to trust it. So let's try this. You know, I kind of want to just make a big, like a big, huge. Yeah, nice big text area for myself to copy down these things. Okay. So that, oh, what is it doing? Why? Okay, it's like, okay, I don't know, it's pulling down a bit too much. I kind of don't think I want to do this actually. That was a lot of random stuff. Okay, maybe let's just go for the simpler option then. I686, but hopefully that shouldn't matter. Okay, I'm gonna. All right, 20-second quick stand up. I'll be right back. Okay, so we have a bunch of tools here now. GRUB. Apparently make rescue is... So anyway, we were able to get a GRUB, so that's cool. I'm just going to quickly look at some of these other instructions just to like kind of it does a lot of complicated stuff here. Install kernel. How old is this? This looks kind of old. Okay. Which GRUB version am I even using? How would I find that out? Make rescue V version 2.2 to 12. So I think we're using GRUB 2. Okay. Multi-boot standard. Magic values in global variables. It recognizes the kernel and knows how to load us. Okay. So now this verify, if you can check whether a file has a valid multi-boot header. Okay, this is super huge. So I guess we'll start out with just trying to add the multi-boot header. What did ChatGPT say for this? I think it's doing it a little bit more simply. I also want to ask ChatGPT about this line. Of all sections, by adding this number, which is kind of big. I want to say it's 16 megabytes. I think 100,000. What's the math again? 1,000 kilobytes. wait, that's, yeah, 100,000 is, it's going to do divided by 256 megabytes. It's moving everything up by 256 megabytes. Interesting. All right, I'm gonna get out of here. Elf 36 read elf. What's it called? JOS GRUB. And we're trying to find load at program header. So this is with JOS GRUB. And this is the normal kernel. And what's the difference? It's very weird. The difference is the virtual address is we no longer have this F here for the virtual address, which actually looks really bad. I think so far that's a pretty important part of the kernel. The fact that it gets loaded so high, so I'm a little bit concerned that that's not there anymore. And then, kind of interestingly, the physical address is way different. Now this is way higher. I'm missing, like, confused by some stuff. Or what are the addressing requirements for using GRUB? Currently, my kernel is linked to be into high memory. Where does GRUB load the kernel? Can I make sure it continues to load it at the same place? By default, you get loaded at physical address 1 megabyte, which is good because that is the same. Well, that's where we used to be loaded. I should have grabbed for multi-boot. Yeah, wait a sec. So Right. We already have a multi-boot header. It's never been used, I think. But something is totally here with it. Yeah, in the current entry.s. So that's very interesting. So technically we should be able to run that command that checks I686 elf grub I686 elf grub file. Maybe just is x86 multi-boot. I think that's what I want. Is x86 multi-boot JOS grub echo stat. I don't know, it's another random file here. That's that. Like, I just want to, this should 1, okay. So that is an error, I think. So, but the fact that this JOS grub thing has a status of 0 is a good sign. Although I don't know if it really says very much, because the kernel also, it just tells us that it found a multi-boot header. Right. So is there just more stuff? So I don't see any other grub related stuff. So literally all it does is just tweak the binary a little bit. Okay, yeah. So what have I learned? I learned that grub will respect the program headers, but you can also optionally override that in your multi-boot header. And we're not doing that. So I am a bit concerned about how this looks. This does not look right to me. Somehow it wiped out this part. Why would it do that. In theory, the bootloader, like GRUB, I should be configuring GRUB to do the exact same kind of loading that the current bootloader already does. I sort of think I want to just keep using the normal kernel. I think this GRUB, just GRUB thing is super suspicious because it seems to make us get loaded way higher into physical memory. But then weirdly, it almost seems like these things are reversed somehow. I sort of feel like this is the better option to go with. So maybe we can just try to see how that will work. So maybe we'll just move forward, assuming that's how to do it. So I think the next thing is going to just be something like following these instructions. So GRUB. And just for learning, I'm just going to type this out by hand. Set timeout equals 0, set default equals 0, menu entry, my hobby OS, multi-boot, boot kernel.elf, boot. Okay, fairly easy. And then maybe it's time to go into the make file. And I'm just going to depend on the kernel, I think. Objdr boot grub. Copy objdr kernel into boot. It's a bit weird. I don't know how to get the root directory, so I'm just gonna do objdr back grub.config to grub, and then something along the lines of i686 elf grub make rescue os.iso okay. So maybe we need isodr. Okay, isodr. Let's just try it. Make GRUB image. Did something. So it did something, yeah. We have is it here? Oh, oops. I'm outputting it to the wrong place. Cool. Now what? So now we can run Kimu differently. Let's try it. All right, quick 20 seconds. This is a quite involved command line. I might just, so you know, if we append a bunch of other random stuff, it's not important for right now. Kimu extra. Then, yeah, just passed along right there. So I think Kimu system. CD-ROM, obj os, obj os.iso, serial, mon.io, whatever that means, GDB. We're probably going to need this. Okay, I don't think this is going to, like, I don't really know what we expect to see here. Oh, but that's kind of cool. We have a GRUB on the screen here. How do I get my mouse? Okay. So GRUB kind of timed out. And now it bumps us over here. It's kind of neat. Okay, so this... Oh, shit. It's not called kernel.elf. It's just called kernel. Okay. Let's make that one more time. And try this one more time. Tree point isn't a segment. You need to load the kernel first. Dang. Isn't in a segment. You need to load the kernel first. Wow. Okay, but I don't know. It's not working, but we at least made a tiny bit of progress. And we have a grub. So I'll consider that a nice incremental piece of progress for this work session. So I'm going to end the stream here, and I'll see you in another one. Peace.